Okay, traders, we are back for more. Woohoo! Okay, so the next page is about proving similarity and using it to find missing sides. So remember, we have three similarity postulates, or three ways to prove that triangles are similar. The first is angle, angle. It means if a triangle shares, if two triangles have the exact same two angles, then we know that their third angle will have to be similar because the three angles in all triangles add up to 180 degrees. So if they share two angles, they have to share the third angle, and they're thus similar. Then we have side, 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 which says if all three sides of a triangle are proportional, then the two triangles are similar. And lastly, we have side, angle, side, which tells us that if two sides are proportional and they share the same angle in between them, meaning that the angle is the same amount of degrees in between the proportional sides, then the triangles are similar. So in this first one, we're going to use one of these three on every one to prove whether they're similar or not. Or if we can't prove any of them, then they're not similar. So we're going to look at this first guy here. It's one of these hourglass setups. You're going to see a lot of these. So the first thing I want you to note is that these parallel lines, or these little arrows, mean that these lines are parallel, okay? And I have this little link here, which helps you with parallel lines. I'm going to attach it to ManageBack as well. You will see it. It tells you how you can figure out that when you have parallel lines crossed by a single line, the angles opposite like this, those are going to be equivalent, and then the mirrored angles here are going to be equivalent, and vice versa, okay? So this line is parallel, and this line is parallel, okay? So that means that this angle and this angle have to be the same size, because the parallel lines are crossed by this single line right here. It also means that this angle and this angle have to be the same size, parallel lines crossed by that line right there. So I already have two angles, so I can prove angle, angle, but I would also know that this angle and this angle are equivalent because they're on either side of two straight lines crossing in an X. So by angle, angle, these are similar. And now let me just, that X part, I'll just re-emphasize it because it'll be helpful throughout your whole math career. If I have two lines that make an X, by definition, that angle and that angle will be the same size. And so therefore with that angle and that angle. And you can just know that. Okay, so the first one is similar by angle, angle. Okay. And it's so, and I just asked you to write down the similarity postulate you use to prove it. So AA. So now B, we're given three sides, okay? We have a triangle of, with sides 12, 15, and 21. We have a triangle with sides 25, 20, and 30, okay? So anytime we're given three sides of each of the triangles, we should assume we're going to be looking for side, side, side. Okay, we're going to try and prove that the sides are proportional. So how are we going to do that? Well, the first thing I would do is I would list the sides of each triangle in order from smallest to largest. 12, 15, and 21. And then on the other triangle, 20, 25, and 30, okay? So what I'm trying to do when I'm proving they're proportional is I'm trying to prove that you can multiply the number on the left by the same thing every time to get the number on the right. Now, sometimes that's really easy to see because it'll be a nice whole number. You like multiply them all by 2, boom, it's proportional. But sometimes like this, it's not a whole number multiplier, okay? 12, you don't multiply by a whole number to get it to 20. So in this case, we need to figure out fraction that is the ratio between these. So to do that, I'm going to write one number over the other, 20 over 12. Okay. And I'm going to reduce it. So what goes into both 20 and 12? Well, 4 does. So I can divide 20 by 4, and I get 5, 12 by 4, and I get 3. So that tells me they are in a ratio of 5/3, okay? Meaning the number on the right will be 5/3 of the number on the left every time if they're similar. So now to prove that, I try and reduce my other, so I know that 20 over 12 reduces to 5/3. So I need to now prove that 25 over 15 reduces to 5/3 and 30 over 21 reduces to 5/3. And I could have made these my numerator. You just need to be consistent. If my first one, my numerator is on my left column, then I need to do it each time. But my first one, my numerator was on the right. So I'm just going to stick with that each time. So I have 25 over 15, and I need to figure out if that reduces to 5/3. And to figure that out, I need to see if I can divide these numbers by the same number to get to these numbers, or vice versa, multiply to get right to left. So I know that 25 divided by 5 is 5, so I have to check, is 15 divided by 5 3? And sure enough, it is. So that means that these sides are in ratio of 5/3. And now, time to do my last one. 30 over 21. I'm going to do the same thing. I'll write it as a fraction. Make sure it reduces to 5/3. Okay. So I look at this guy right here and I say, okay, 30 divided by what equals 5? 30 divided by 6. So does 21 divided by 6 equal 3? No. 21 divided by 7 equals 3. So that means that 30 over 21 is not equal to 5/3. Okay, it's actually equal to 10/7, which would be 5 over 3.5. So this one is not in ratio of 5/3. Therefore, my triangles are not similar. So for this one, I would write, basically, you can just write, and this is a correct statement and factually accurate. You could write 30 over 21 does not equal 20 over 12. Okay. And that proves that they're not similar because they're not proportional. So number 2 is not similar. Now, 3, or C on question 4, that's going to give us a new trick. So we have 2 angles and we have no sides. So we're going to have to use angle-angle theorem. Okay, now don't fall into the trick here. We've got 74 and 47 and 47 and 58. I'm drawing this on my Jamboard, but it's really ugly. And 58. Okay. So we know that each shares the 47. But don't just look at this and say, well, 58 is not 74, so they can't be similar, because this angle could be 58 shared with that one, or this angle could be 74 and shared with that one. So to check that, we have to remember that all of the sides in it, all the angles in the triangle will add up to 180 degrees. So 58 plus 47 plus this angle right here will equal 180. So 58 plus 47, that's 105. 98 plus 7, 105. So 105 plus A will equal 180. 105 plus what equals 180? 75. So that means that this angle has to be 75. And now I can check, is 75 the same as 74? No, it is not. Okay, therefore they don't share 2 angles. Therefore they are not similar. Okay, so that was C. So only one of ours was similar. The first two, the other two pairs were not similar. Okay, so now we're going to do 5. Find the value of x in the similar triangles at right. We'll write them out. We have a triangle. So here we're told they're similar. Okay. We know they're similar. We just need to figure out what the proportion is. Okay. So there's a few ways we can do this. We can know that 16 over 24, okay, which is going to be that over its corresponding side, will equal x over 21, our other corresponding sides. It's going to equal x over 21. Okay. So you could reduce these to the same fraction. I'll show you how to do that. I would think, what could I divide both my denominator, or what goes into both my denominators? 3. Okay. So to get from 24 to 3, I divide by 8. So 24 divided by 8 would give me a denominator of 3. Now I need to do the same to my numerator. So 16 divided by 8 will give me 2/3. Okay. So I can reduce 16/24 to 2/3. And now I need to figure out what is 7x over 21 if it's equivalent to 2/3, because that's our ratio. So I think 3 times what equals 21? 7. I do the same to my numerator. 2 times 7 is 14. So my numerator is 14. So x is 14. Now the other way you can do it is you can cross multiply and divide. So remember, you multiply your numerators by the opposite denominator. So 16 times 21 equals 336. And 24 times x equals 24x. I now divide by 24, and x equals 336 divided by 24, or 14. Okay, last guy. Get another one of these in the hourglass shape. So again, we are told they're similar, and we're looking for x, y, and z. Okay, and for this guy, I'm just going to copy the screenshot onto my Jamboard. Then remember that I had you switch that 5 to a 4 to make your lives easier. So I'm going to add an image. It's going to be there. So we want to find x, y, and z. Okay. So we'll start with x and y. So if that 5 is a 4, okay, so the only sides I have that are corresponding now are 4 and 12. Remember, so how can I tell? Well, my 4 is right next to this 40-degree angle, just like my 12 is, okay? Sure, the long side is, but x is the long side. So 4 is going to be equivalent to my 12 side. You can also remember that anytime you have two triangles in that hourglass shape, it's like one is inverted. So I know that my sides are in ratio of 4 to 12. Okay, so that's going to be equal to 10 over x, or 8 over y. We'll do both of them. We'll start with 10 over x. Okay, so 4 over 12 equals 10 over x. So we need to think about reducing this fraction down. Okay, I can divide 4 and 12 by 4. It's going to reduce to 1/3. So I know that my triangles are in ratio of 1/3. So then I know that 10 over x will be in ratio of 1/3. So I think 1 times what equals 10? Well, that's 10. I do the same to my denominator. 3 times 10 equals 30. So that tells me that x equals 30. Okay. So right there, I've got 30. And now I can do the same for y. I've got 8 right here over y Okay. 8 over y. I'm going to do the same thing. I remember that 4/12 reduces to 1/3. It's going to equal 8 over y. I know they're similar, so I know that these ratios will be equivalent. 1 times 8 equals 8. So 3 times 8 will equal y. Y is 24. Y is 24. Now, to find the angle z, I have to use the fact that my angles will all add up to 180 because it's a triangle. Every triangle, the angles all add up to 180. Don't forget it. You'll use it plenty. So this will be 110 because it's across from that and an x. So I know that two of my angles are 110 and 40 plus z, this bad boy, that will equal 180. So I can add 110 and 40, which is 150. So 150 plus z will equal 180. And I can subtract 150 from both sides to isolate z. Z equals 30. Bada bing, bada boom. So x is 30. Y is 24. And z is 30. All right, I'll record a third video for the last page.